layer absorptance option allow you to represent a level of absorptance for individual layers of a design as a function of the wavelength or incident angle. In this video example, we would like to demonstrate how to calculate absorptance in separate layers of silicon-based thin film solar cell structures. Here, in this picture we can see a solar cell structure. The coating consists 5 layers, the incident medium is glass, and substrate is air. This film structure and optical constants that we use in this example are taken from the famous paper of Zeeman. You can see the corresponding reference on the screen. Let's see how Optilayer will calculate layer absorptance in separated layers. We prepared 5 different layer materials that used in this paper. All the materials have unique names for each other, and all refractive indices are taken from the paper. We also prepared abbreviations for every layer materials that used in this video example. As you can see on the screen, these abbreviations are quite simple and convenient. Then we prepared 5 layer structures, which are the same as in the article. After that, we load air as a substrate and glass as incident medium. Finally, we load 5-layer structure. Now we see there the reflectance, but we change the plot for absorption values. So, now we can observe an absorption in the whole structure. We would like to analyze absorption in separate layers. We will use a special analyze option, layer absorption. In settings window we specify a num of layers. In our example, we would like to observe absorption for layers number 2, 3, 4. As you can see, the start layer is number 2, and end layer is number 4. Then we can see an absorption in specified layers. Typically, all the incoming photons are converted into electric charges in the 3rd layer, for this example coating structure, of course. It is possible to maximize the amount of light absorbed in the 3rd layer by optimizing the thicknesses of other layers. Let's look how it works. First of all, we need to create a new absorption target. As you can see, for this type of targets we have a special tab. By pressing the new button, we are starting to create absorption target function. In the target settings window we specified a required spectra. In this example, the spectral range begins from 400 nanometers and ends at 800 nanometers. The grid step is equal to 5 nanometers. Spectral characteristic is absorption. We specified the absorption value equal to 100% because we need to obtain the maximum absorptance in this optical design. After that, we press Targets button. In this window we specified the abbreviation for material, which we need to optimize to obtain the required values of absorptance. We want to optimize the 3rd layer. Its abbreviation is IASI. That's enough for specification of absorptance target. Then we press OK button, and now we can see the correct material in target's specification window. Well, after that we load this target. But before we start optimization, we need to fix the structure of the design, because it must be unchanged. The limitation thicknesses and the order of layers in design are very important for us. So, in this case we cannot use simply refinement optimization. For this task, we can only use constrained optimization, because it allows us to set the limitations for layer thicknesses. You can see on the screen the constrained optimization settings window and limitations for each layer in the constriction. After we set and check all the limits, we can press Apply and Run button, and in some second we obtained a good result, which you can see on the screen. We obtained a 5-layer solution with optimized absorption in layer number 3. As you can see, a merit function has decreased from 61 to 57. We can save our design with another name. Now, we can compare the new and the old designs and one more time to see that the layer absorption in layer 3 more than has the same layer in the old design. We can also open Design Structure window and see that all the layers are inside the specified boundaries.